All right, so we're condensing 2 sections only in Chapter 9. Chapter 9 is triangle trigonometry. So the chapter begins with right triangle trigonometry, which you guys have studied since geometry. That's our SOHCAHTOA. In a right triangle, we can write the relationship between the angles and sides. We know that the sine of the angle is opposite side over hypotenuse. Cosine of the angle is the adjacent side to the angle over the hypotenuse. And the tangent of the angle would be the opposite side over the adjacent side. We are going to give you a few problems to work on with that. Let me remind you of our inverse functions. So now this is to find a missing side length or a missing angle measure. So remember, if I can set up my sine ratio to find the missing angle measure, I take the inverse sine of that ratio opposite side to hypotenuse. Likewise, if I set up the cosine ratio to find the angle measure, I take the inverse cosine of the adjacent side to the hypotenuse. And lastly, inverse tangent of opposite side over adjacent side. So remember that inverse function is always used to solve for angle measures, and that's what you worked on in all of Chapter 8. So we're going to look at non-right triangles and finding missing side lengths and angle measures. We do that using the law of sines and the law of cosines. You may have seen this briefly in geometry or algebra 2, but I'm not sure if you got to that. All right, I'm going to do 4 examples because you need to look at the notes that were assigned as well, and then these are just examples of each kind. All right, so law of sines. The law of sines is the ratio of an angle measure to its corresponding side. The ratios can be set up with the angle measures in the numerator and the side lengths in the denominator, or the side lengths in the numerator, the angle measures in the denominator. Our lowercase letters are always used to represent side lengths. Our uppercase letters are always used to represent angles. So I put this on here, just for you to be able to check out. When do you use law of sines? There's 2 cases when you do it. I included the pictures, okay? Likewise, for law of cosines, there's 2 cases when you would use it and what you're to look for. Now, don't get caught up in the A, B, and C. All that those things represent are angles and their corresponding sides. So if I make this little side length A, then opposite little side length A is going to be capital A, its angle measure. Students, when they do this, they get so caught up in the letters that you're missing the relationship between the sides and the angles. If I named this side M, then opposite side M would be angle M. Okay, so angles and sides correspond to each other in a triangle when they're opposite of each other. Now, there's your relationship for your law of cosines. Oh, notice, these are my little letters, right? Side length, side, 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 side. Now I have a capital C. So that's my angle measure. Now, when we set up law of cosines, the angle measure and its side have to be opposite of each other in the triangle. Okay, and I'm going to do an example of both. Okay, so I put the cases on there. You can read over them, but you're going to be doing all these things on your own. So you do whatever you need to. When I look at this, I want to find the measure of angle C. Here's my unknown angle. All right, well, what information am I given? So when I look at this, angle C is opposite side length 15. 120 degrees, side length B, it's not opposite any other angle measure. Okay, so let me go back. Angle C is unknown. It's opposite of side length 15. Angle 120 degrees is known, and the side that it's opposite of is unknown. So when I look at my angle measures to set up my law of sines, so the sine of angle C over its corresponding side length of 15 would be proportional to the sine of 120 degrees over its missing side length little b. Well, hopefully you're saying to yourself, well, this is wrong. I can't have one equation with two unknowns. So my law of sines can't be the first law that I use. This is a multi-step problem. So now let me go back, and I'm going to erase these. From my one angle measure, if I know the measure of angle B, I can find the length of side B because I have my other side lengths of 15 and 19. So these are like my bookends. Little b I don't know, and 120 degrees I do know. So remember what I said. They have to be opposite of each other in the triangle. Now I just fill in 15 and 19. It doesn't matter my order. So the side I'm looking for squared is equal to the sum of the other two sides squared minus 2 times A times B times the cosine of 120 degrees. All right, well, solving this, notice all of your values are on the same side of the equal sign. Plug it in your calculator exactly as is. Okay, so now when I'm using my calculator, I have to make sure that my mode is in degrees, which it's not. So first thing I'm going to do is change my mode to degrees. And now since all the numbers were on the right side of the equal sign, 15 squared plus 19 squared minus 2 times 15 times 19 times the cosine of 120. 871. Hopefully you're saying to yourself, this doesn't make sense. If my other two side lengths are 15 and 19, 871 doesn't make sense. Don't forget that you have to take the square root of that value. So then my third side would be 29.5. Okay, so now I'm going to erase this. Okay. Now I know that this side length is 29.5. So now remember, we're looking for the measure of angle C. So here I have the measure of angle C, and we already determined that angle C is opposite side length 15. And now we have another ratio between a known angle measure and its side length. Now I can complete my law of sines. The sine of angle C, that's my unknown, over 15, is proportional to the sine of 120 degrees, and we found its corresponding side length to be 29.5. Now please, let's recall all the things we've ever learned about solving proportions. I'm going to multiply both sides by 15. All right, perfect. I'm looking for a missing angle measure. So the measure of angle C, I have to take the inverse sine of this entire ratio. Now, we have nice calculators that do all the work for us. So I want you to plug it in the calculator exactly as it's written. Don't approximate that value and then do the inverse sine. Let the calculator do all the work for you. Okay, so my mode is still in degrees here. Now I do second sine, inverse sine of 15 times the cosine of 120 degrees. Nope. Sorry. All right, sorry about that. Inverse sine of 15 times the sine of 120 degrees. Remember, you have to close the parenthesis after that 120 or you ruin your order of operations. And then that was divided by... Did I plug this in wrong? Hold on. Sorry. Divided by 29.5 and my parenthesis. So now to the nearest degree, my missing angle measure, the measure of angle C would be 26 degrees. Please read directions. You are not reading directions and therefore your answers are wrong. Round accordingly. Okay, so again, this was a really good problem because we could use the law of sines, but in order to use the law of sines, we had to use the law of cosines first.